Happy Wednesday, 5th grade. Today is mission 6, lesson 6. We're going to continue with the coordinate plane, but we're going to have fractions as our coordinate units. Before we get started, let's remind ourselves of these three key terms that we defined yesterday. Students, on your own, go ahead and fill in the definitions of parallel, intersecting, and perpendicular lines, and draw one example of each. Let's take a few minutes to do that now. It's okay if your words and examples don't exactly match mine, but remember, parallel lines are two lines that will never meet, like these two pairs of lines. Intersecting lines are two lines that meet at a given point, like these two lines here meeting at these 2 points. Perpendicular lines are a more specific type of intersecting lines. They are intersecting lines that form 1, 2, 3, 4 right angles, like this large plus sign here. Now that we have those key terms defined again, let's move on to we do number 1. Now, in this lesson, we're going to be asked to plot points where the x and y values, the coordinates, the numbers that we have to climb and crawl, are going to be fractions. So first, let's look at this coordinate plane. Let's ask ourselves, what fraction are the units in this coordinate plane being broken up into? Because this plane looks a lot different than yesterday's plane. Yesterday's plane, each unit was just worth 1. In between 0 and 5, there are 1, 2, 3, 4 whole units. But in today's coordinate plane, we have a whole bunch of units before we even get to 1. But I think drawing a tape diagram within our coordinate plane will help. Let's pretend that from 0 to 1, this little chunk right here, let's make an area model right here. And let's partition our area model along the lines in the plane. And just by looking at this, we know that this is an area model for 1/4, right? It's partitioned into 4 equal parts. So we know each of these units is going to be 1/4. We can label this line on the x-axis 1/4. This would be 2/4, 3/4, and then once we get to 4/4, that is again 1 whole. Let's draw another area model from the 1 on our x-axis all the way to the 2. And partition it the same way. As we can see, it's still broken up into fourths. It's another area model for fourths. If our blue area model is showing us 1 whole with these 4/4, then if we keep going, this would be 1 and 1/4. This would be 1 and 2/4, 1 and 3/4, and then once we got to 1 and 4/4, that would just be 2. And then we would keep going from there, 2 and 1/4, and so on. So each unit in the coordinate plane, both on the x-axis and the y-axis, is going to be worth 1/4. That answers our question right here. What fraction are the units in this coordinate plane broken up into? They're broken up into fourths. You can show it with a fraction or just write fourths. How do we know? Teachers, let's pick a stick here. Who can explain how do we know this coordinate plane is broken up into fourths? Your wording may have differed from mine, but the key point here is that there are 4 units in between each whole number. 1, 2, 3, 4 to get to 1, 1, 2, 3, 4 more to get to 2, and so on. All right, let's make sure we have these two in our notes, and then we will move on. Now we're going to take a similar coordinate plane, one that is also broken up into fourths, and we're going to plot some points on it. I'm going to add some labels in here just to help me because this is a little new. In between 0 and 1, I'm going to label each unit by fourths, starting with 1/4, 2/4, and 3/4. And then I'm going to do the same thing on the y-axis. 1/4, 2/4, and 3/4. You know what? Let's go ahead and label the whole thing. Continuing on the x-axis, we have 1, then 1 1/4, 1 2/4, 1 3/4, 2, and then 2 1/4. Finally, 2 2/4, which we could also call 2 1/2. Continuing on the y-axis, we have 1, 1 1/4, 1 cat interruption. 1 2/4, 1 3/4, 2, 2 1/4, and then finally again 2 2/4, which could also be written as 2 1/2. Keep an eye on that while you're doing your Zern mission. They'll often ask you for the most simple version of a fraction, so 2 2/4 they may want you to input as 2 1/2. Let's pause here for a moment and make sure we all have our coordinate plane x and y axes labeled. Now we'll thank ourselves for the work of labeling our y and x axes when we go ahead and plot these points with fractions as coordinates. Again, I'm going to give myself the reminder that my x is my crawl and my y is my climb. For the square, I have a crawl of 3/4 and a climb of just 1/4. Square goes right there. The triangle, the same crawl of 3/4, but then the climb is going to be also 1, 2, 3/4. Triangle's right there. Moving on to our trapezoid, same crawl again, 3/4, but this time the climb is going to be 1 1/2, which we know is equivalent to 1 2/4. Trapezoid, right there. Rhombus is at 0.3/4, 2 1/4. Let's go ahead and students, you can go ahead and plot the rhombus on your own. Let's take 20 seconds to plot the rhombus. Right now, we have all 4 of our shapes created. Now we're going to connect all of the shapes with a line and name that line line S. Now, since all of our shapes here have an x value of 3/4, we're pretty much drawing a line right along this 3/4 line from the x-axis all the way up. Let's make sure we have line S drawn and labeled. Now, just like yesterday, we do number 3 is going to be asking us questions about the points in line that we created on we do number 2. Question 1, how many units is line S away from the y-axis? Okay, well, here's my y-axis. Here's line X, so it must be 1, 2, 3 units away. So my answer must be 3. Students, do you agree or disagree? Am I 3 units away from the y-axis at line S? What do we think? Well, welcome back. I'm wondering if I inspired a little bit of a debate with how many units these two lines are from each other. Because when I first looked at it, I thought, okay, it's 1/4, 2/4, it's 3/4 of a unit away. But when it comes to coordinate planes, we think of our units as lines. So even though these 1, 2, 3 units are only worth 1/4 each, they're still 3 units. 1 unit, 2 unit, 3 units, and they're only worth 1/4. No matter what our units are worth, 1 unit on the coordinate plane is 1 unit. So line Y and S are in fact three units apart. Question 2, is line S parallel, intersecting, or perpendicular to the y-axis? Let's draw orange line here to represent the y-axis. So these two lines, Y and S, teachers, let's pick a stick here. Are they parallel, perpendicular, or intersecting? And these lines are parallel. They're not intersecting because they never meet. They are parallel because they're never going to meet as far as we draw them out. And who teachers pick a stick for somebody to tell us why are these two lines, Y and S, parallel but not perpendicular? Why are they parallel but not perpendicular? Let's pick a stick. They are parallel because they're never going to touch, but they are not perpendicular because they don't meet to create 4 right angles. In fact, they don't meet at all. They're not even intersecting. So if you're not intersecting, you can't be perpendicular. You can kind of think of this like our shapes rules. If you're not even a parallelogram, you're not going to be a square, right? All right, let's take a moment to make sure we do number 2 into our notes, and then we will move on. Just kidding, we forgot to talk about the x-axis. Part 3 of we do number 3 is line S parallel, intersecting, or perpendicular to the x-axis? We know that it's parallel to the y-axis. Now, let's look at line S in relationship to the x-axis here. Teachers, let's pick another stick here. Is line S parallel, perpendicular, or intersecting with the x-axis? Line S intersects, it is intersecting with the x-axis because they meet at a point right here. They meet at 0, or they meet at 3/4 and 0 would be the coordinate that they meet at. Now, who can explain to us why line S and the y-axis, line S and the x-axis are not perpendicular? We know they're intersecting. They meet right here. Why are they not perpendicular, though? Who can tell us? These two lines are intersecting but not perpendicular because they don't meet to create 4 right angles. They create 2 right angles here and here. If our line S extended past the x-axis to create 4 right angles, it would be perpendicular. But since it doesn't, they're only intersecting. Let's make sure we have those 3 questions for we do number 3 answered in our notes, and then we'll move on to our exit ticket. The exit ticket today is very similar to yesterday's exit ticket. You're going to plot 4 different points in order to create a line and then answer some questions about that line and its relationship to the y and x axis. Only difference being today's coordinate points are fractions instead of whole numbers. So let's go ahead and plot the first point, the square, together. And as always, I like to remind myself of the x being my crawl and the y being my climb. The square is at coordinates 1/4. You can label these if you want to. We know that each unit is 1/4. 1/4 by 1 and another 4th. 1/4 by 1 and 1/4. Once you've plotted the triangle, trapezoid, and rhombus, created line T, make sure to go to the next slide, the final slide, to answer 3 questions about line T, and then click Turn In on your notes.